Download this code from codegive.com, link in the description below. Twincat 3 PLC HMI tutorial, error analysis with core dump and code example. This tutorial provides a comprehensive guide to error analysis in Twincat 3 PLC HMI projects, focusing on generating and analyzing core dumps. We'll cover identifying different error types, configuring core dump generation, analyzing core dumps with the Twincat crash dump analyzer, and using code examples to demonstrate common error scenarios. Understanding errors in Twincat 3. Twincat 3, while robust, is susceptible to errors arising from various sources. Recognizing the different types of errors is crucial for effective debugging and resolution. Here's a categorization of common error types. *PLC errors, runtime errors. These errors occur during the execution of your PLC code. They can be triggered by division by 0, attempting to divide a variable by 0. Array index out of bounds, accessing an array element beyond its defined boundaries. Pointer errors, dereferencing a null or invalid pointer. Stack overflow, calling functions recursively without proper termination, leading to stack exhaustion. Uninitialized variables, using variables before they have been assigned a value. Data type mismatch, trying to assign a value of one data type to a variable of an incompatible data type. Exception handling, exceptions in .NET components, errors arising within .NET components called from the PLC. Configuration errors, these errors occur due to incorrect configuration of the Twincat system. Examples include missing or incorrect device drivers, lack of proper drivers for connected hardware devices. Conflicting hardware assignments, multiple devices attempting to use the same resources. Communication problems, issues with communication protocols, example EtherCAT, Modbus. Hardware errors, failures in the underlying hardware components. These can be more difficult to diagnose and often require physical inspection and testing. HMI errors, errors specifically related to the human-machine interface, HMI. These can include data binding issues, problems connecting HMI elements to PLC variables. Scripting errors, if using HMI, scripting errors in the HMI script logic, example JavaScript, C. UI element issues, problems with the display or functionality of HMI controls. 2. Core dumps, a snapshot of errors. A core dump, often referred to as a memory dump or crash dump, is a snapshot of the system's memory at the time of a crash or unhandled exception. It contains valuable information about the state of the PLC program, including variable values, the values of all variables at the time of the crash. Call stack, the sequence of function calls that led to the error. Program counter, the address of the instruction that was being executed when the crash occurred. Thread information, information about the threads running in the PLC program. Error information, details about the type of error that caused the crash. Core dumps are invaluable for debugging complex errors that are difficult to reproduce or analyze through conventional methods. They allow you to examine the exact state of the system at the point of failure, providing clues about the root cause of the problem. 3. Configuring core dump generation. By default, Twincat may not be configured to automatically generate core dumps upon encountering an error. You need to explicitly enable this feature. 1. Twincat XAE, Visual Studio. Open your Twincat XAE project, Your PLC solution. Asterisk navigate to the Solution Explorer. Asterisk right-click on your PLC project node, the one with the PLC icon. Asterisk select Properties. Asterisk in the PLC Settings tab, usually the default, locate the Crash Dump section. Asterisk enable Crash Dump generation. Asterisk set the Enable Crash Dump option to True. Asterisk Crash Dump location. Asterisk specify the directory where you want the core dump files to be saved. A good practice is to use a dedicated folder. The default location is usually within the Twincat installation directory, but placing it on a separate drive or folder can make access easier, especially if the primary drive is heavily used. Example, see /Twincat_crash dumps. Asterisk crash dump count. Asterisk set the maximum number of core dump files to keep. This prevents the drive from filling up if crashes are frequent. A value of 5 to 10 is usually sufficient. Asterisk crash dump size. Asterisk define the maximum size of each core dump file. The size depends on the complexity of your PLC program and the amount of data you want to capture. Experiment to find a suitable size. Be mindful of disk space. Asterisk crash dump trigger. Asterisk the setting determines when a core dump is generated. The options are: asterisk on exception. Asterisk generate a core dump only when an unhandled exception occurs. This is the recommended setting for most cases. Asterisk on breakpoint. Asterisk generate a core dump when a specific breakpoint is hit. This can be useful for debugging specific sections of code. Asterisk on error. Asterisk generate a core dump on any error. This can lead to a large number of dumps. Asterisk crash dump timeout. Asterisk sets a timeout for the core dump generation. This is useful to prevent the system from getting stuck if the core dump process is taking too long. Asterisk important note. Asterisk after making these changes, rebuild and reactivate your Twincat project for the new settings to take effect. To Twincat System Manager, for runtime configuration. Asterisk while the ideal approach is to configure core dumps in the XAE project, you can configure them through the Twincat System Manager, especially if you are connecting to a running system without the project. Asterisk open the Twincat System Manager. Asterisk navigate to your PLC runtime. Asterisk select the PLC tab. Asterisk you should see the same crash dump settings as in the XAE project. Modify them accordingly. Asterisk important. Asterisk changes made in the System Manager are only applied to the runtime system and are not persistent across restarts. 4. Code example, triggering errors for core dump generation. Let's create a simple PLC program that intentionally triggers different types of errors to demonstrate core dump generation and analysis. Explanation asterisk. Asterisk error 1, division by 0, handled with exception handling. Asterisk the divide numbers function attempts to divide a number by 0 if n-divisor is 0. Instead of crashing the PLC, the try, catch block will catch the potential exception and set the result to 0.0. This avoids a hard crash. Asterisk important. Asterisk exception handling provides a mechanism to gracefully recover from errors without halting the entire runtime. Asterisk note. Asterisk to trigger a full crash core dump, you can remove the try, catch block and uncomment the line n result equals 10/n-divisor. This will cause an unhandled exception, triggering a core dump if configured. Asterisk error 2, array index out of bounds. Asterisk. Asterisk the code attempts to access ARR data n index, where n index is set to 6. Since the array is defined as array15, this access is out of bounds and will lead to a runtime error if btrigger error is true. Asterisk error 3, null pointer dereference, commented out. Asterisk this line, p-pointer caret equals 200, attempts to write a value to the memory location pointed to by p-pointer. If p-pointer is null, meaning it doesn't point to a valid memory address, this will cause a crash. This is extremely dangerous and can corrupt the system's memory. Only uncomment and test this under controlled conditions. Error 4, stack overflow, recursive function, commented out. A recursive function calls itself. Without a proper stopping condition, this can lead to excessive function calls, consuming the stack memory. This can lock up the runtime. This example is very simplified. Real-world stack overflows usually involve more complex recursive logic. Warning: uncommenting and calling this function will likely freeze the Twincat runtime. Only use it for controlled testing to demonstrate core dump generation. B trigger error this Boolean variable controls whether the error-inducing code is executed. Set it to true in the online mode, Twincat debugger, to trigger the errors. Triggering errors and generating core dumps. 1. Download and activate download the PLC program to your Twincat runtime system and activate the configuration. 2. Online mode go online with the PLC, in the Twincat debugger. 3. Set B trigger error to true in the online view, change the value of the B trigger error variable to true. This will cause the PLC program to execute the error-inducing code. 4. Observe the results If you've configured exception handling correctly, like in the divide numbers function, the system may not crash. You'll see the catch block executed and the program continue. If you trigger an unhandled exception, example uncommenting the division by 0 without the try, catch, or the array out of bounds, Twincat should detect the error, halt the PLC, and generate a core dump file in the directory you specified in the crash dump location setting. The Twincat XAE, Visual Studio, environment might freeze or display an error message. 6. Analyzing core dumps with the Twincat Crash Dump Analyzer. Once a core dump file is generated, usually a .cdmp file, you can use the Twincat Crash Dump Analyzer to examine its contents. This tool helps you pinpoint the source of the error. 1. Open the Crash Dump Analyzer ***. The Crash Dump Analyzer is typically installed with the Twincat 3 installation. You can find it in the Twincat installation directory or by searching for Twincat Crash Dump Analyzer in the Windows Start menu. 2. Load the core dump file ***. In the Crash Dump Analyzer, click File - Open and browse to the directory where your core dump files are saved. Select the .cdmp file you want to analyze. 3. Symbol files, .tsym. The Crash Dump Analyzer requires symbol files, .tsym, to map memory addresses to meaningful function names, variable names, and line numbers. Without symbol files, the core dump analysis will be much less informative. Symbol files are generated when you compile your Twincat project. Ensure that you have the .tsym files for the exact version of the PLC code that generated the core dump. The Crash Dump Analyzer usually automatically detects and loads the symbol files if they are located in the same directory as the core dump file or in the same directory as the PLC project. If the symbol files are not found, you can manually specify their location by going to Options - Symbol Paths in the Crash Dump Analyzer. 4. Interpreting the analysis exception information the analyzer will display information about the exception that caused the crash, including the exception code, address, and description. This is crucial for understanding the type of error. Asterisk call stack asterisk the call stack shows the sequence of function calls that led to the crash. This is invaluable for tracing the error back to its source. Look for your PLC program's function names in the call stack. Click on the stack frames to see the code around the point of failure. Asterisk variable values asterisk the analyzer allows you to inspect the values of variables at the time of the crash. This can help you understand the state of the program and identify any unexpected values that may have contributed to the error. Use the Locals and Globals tabs to view variables. Asterisk disassembly view asterisk the analyzer can display the disassembled machine code around the point of the crash. This is useful for advanced debugging when you need to understand the low-level details of the code execution. Asterisk modules view asterisk displays loaded DLLs. Useful for troubleshooting dependencies. 7. Example core dump analysis. Let's say you triggered the array index out of bounds error in the example code. After loading the core dump in the crash dump analyzer, you might see something like this. Asterisk exception information asterisk the exception code might indicate an access violation or memory access error, suggesting a problem with memory access. Asterisk call stack asterisk the call stack will likely show the PLC_PRG program and the line of code ARR data n index equals 100, as the point of failure. Asterisk variable values asterisk inspecting the value of n index would reveal that it is 6, which is outside the bounds of the ARR data array, 15. From this information, you can immediately identify the cause of the error as an array index out of bounds. 8. Best practices for error handling and debugging. Asterisk use structured error handling asterisk employ try, catch blocks to handle potential exceptions gracefully. This prevents crashes and allows you to log errors or take corrective actions. Asterisk validate input data asterisk check the validity of input data before using it in calculations or operations. This can prevent errors caused by invalid data. Asterisk assert statements asterisk use assert statements to check for conditions that should always be true. If an assertion fails, it indicates a potential bug in your code. Assert is primarily useful during development, as it is typically disabled in release builds. Asterisk logging asterisk implement a robust logging system to record errors, warnings, and other relevant information during program execution. This can help you diagnose problems that are difficult to reproduce in a debugging environment. Use tctrace to send logs to Visual Studio during development. Asterisk code reviews asterisk have your code reviewed by other developers to catch potential errors and improve code quality. Asterisk unit testing asterisk write unit tests to verify the correctness of individual functions and modules. Asterisk regular backups asterisk regularly backup your Twincat project files and system configuration to prevent data loss in case of a hardware failure or other disaster. Asterisk proper memory management asterisk if you are using pointers, make sure to allocate and deallocate memory correctly to avoid memory leaks and other memory-related errors. Asterisk watchdog timers asterisk implement watchdog timers to detect if the PLC program gets stuck or enters an infinite loop. The watchdog timer will reset the PLC if it doesn't receive a signal within a specified time. Asterisk Twincat scope view asterisk use Twincat scope view to monitor the values of variables over time and identify any unexpected behavior. Asterisk symbolic breakpoints asterisk use symbolic breakpoints in the Twincat debugger to stop the program at specific locations in your code based on variable values or conditions. 9. Advanced core dump topics. Asterisk remote debugging asterisk you can analyze core dumps generated on a remote Twincat system. To do this, you need to copy the .cdmp file and the corresponding .tsym files to your development machine. Ensure that the Twincat version and the runtime target platform, example x86, x64, are the same between the remote system and your development machine. Debugging optimized code. When you compile your PLC program in release mode, the code is optimized for performance. This can make debugging more difficult because the debugger may not be able to step through the code line by line, and the values of variables may not always be available. Consider disabling optimizations for debugging purposes or creating a separate debug build configuration. Custom exception handling. You can define your own exception classes and handlers in Twincat 3. This allows you to handle specific types of errors in a more customized way. Core dump filters. You can configure filters to control which types of exceptions trigger core dump generation. This can be useful for reducing the number of core dump files that are generated. Conclusion. Error analysis with core dumps is a powerful technique for debugging complex problems in Twincat 3 PLC HMI projects. By understanding the different types of errors, configuring core dump generation, and using the Twincat crash dump analyzer effectively, you can significantly reduce the time it takes to diagnose and resolve issues. The combination of proactive error handling, try, catch, robust logging, and the ability to analyze core dumps when the unexpected occurs will improve the reliability and maintainability of your Twincat applications. Remember to prioritize proper symbol file management, as they are essential for meaningful core dump analysis.